Good day everyone. My name is Austin J. Diharlo Colyanto, a third year mechanical engineering student, and this subject is thermodynamics 2. My topic is about real gas. So real gas. What is real gas? Real gas is a gas that does not behave as an ideal gas due to interactions between gas molecules. So, a real gas is also known as a non-ideal gas because the behavior of a real gas is only approximatedly by the ideal gas law. So, if we say a real gas, it is a non-ideal gas because of the interactions between the gas molecules. Real gases. For real gases, the product of pressure and volume is constant. So if there is ideal gas, if the pressure is and volume is constant, so we can say that it is a real gas, ideal gas, sorry. While real gas deviate somewhat as shown by the graph pressure versus the ratio of observed volume to ideal volume below. So these are the graph pressure versus the ratio observed volume. So the black line, it is the ideal gas, while the green one, it is N2 or nitrogen, and it has oxygen, hydrogen, carbon dioxide, and water H2O. So this number 100, 200, 300, 600, 800, 900, it is pressure in atmosphere, while the 0.5, 1, 1.5 to 2.5, it is the volume observed or the volume ideal. This deviation occur when real gases do not actually have zero volume, and the polar gas particles do attract if compressed. So that's it. Real gases. Under many conditions, real gases do not follow the ideal gas law. So why is real gases do not follow the ideal gas law? It is because intermolecular forces of attraction cause the measured pressure of a real gas to be less than expected. So because of the intermolecular forces of attraction, so that the real gas is measured less than expected. So when molecules are close together, the volume of molecules themselves become a significant fraction of the total volume of gas. So if the molecules are close together or compressed, the volume of molecules themselves become a significant fraction. So we have here the van der Waals equation. Open parenthesis P plus N squared A divided by V squared close parenthesis open parenthesis V minus NB N times B close parenthesis equals nRT. So this is the van der Waals equation. Properties of real gases. So here are the properties of a real gas. Real gas has no definite shape or no definite volume. So real gas does not have a definite shape and definite volume. Real gas expands to fill the container. Yes, it can because real gas has no shape and no definite volume. So real gas also has low density. Real gas is compressible, exhibits diffusion and effusion. So what is diffusion, guys? Diffusion is spreading out of particles from high concentration to low. So when we say diffusion, it is the spreading of particles from high concentration to low. While effusion, it is the process that particles pass through a small opening. So if the particles passes a small opening, it is called effusion. So the behavior of real gases. Corrections for non-ideality require van der Waals equation. Here are the corrections. So open parenthesis P plus A times n squared over V squared close parenthesis times V minus n times B close parenthesis equals to nRT. So excluded volume, intermolecular volume. So this one, guys, is the intermolecular attractions, while the other one is excluded volume. So here are the difference between the ideal gas and the real gas. First, the definition. Ideal gas is an equation which states the behavior of an ideal gas, while the real gas law is derived from the ideal gas law in order to fit the behavior of real gases. So, the theory. Ideal gas law describes the behavior of a theoretical gas, while the theory of the real gas describes the behavior of actually occurring gases in the universe. So here are the difference of the equation. Real gas is ideal gas is PV, P times V equals to nRT, N times R times T. And the real gas is P plus A N squared divided by V squared Vm minus B is equals to N times R times T. So the specifications. Ideal gas law has no specific components added because this equation is for an ideal gas. So while the real gas law has added a pressure components and a volume component to the ideal gas equation. So it is very different between the ideal gas and real gas in definition, theory, equation, and specification. So we have the kinetic molecular theory of real gases. KMT, or kinetic molecular theory, describing particles in a real gas have their own volume, attract each other, and the gas behavior is most ideal at low pressures, at high temperatures, in popular atoms or molecules. So the behavior of a gas depends at low pressure, at high temperature. And that's all for the real gas. Thank you.